Okay, this is going over valence and other types of chemical bonds. Valence is referring to your outermost electrons. When we refer back, we look at Dalton's atomic theory, and he gave us a basic understanding how atoms might combine. If you recall, there was a problem with his because he said that they did not break up. Okay? Later on we find out the electrons are what's responsible for bonding. You have demonstrated throughout your labs how atoms react together to form compounds. So, upon all of this and understanding the periodic table, we now know that the bonds are dependent upon the valence electrons, which are the electrons in the outside shell, which also relates back to the sp, d, and f blocks. And scientists use empirical knowledge to deduce rules of bonding. We look at our labs to determine the ratio represented between two atoms. And you will be doing labs shortly where you will actually determine the empirical formula of certain compounds. Valence electrons were first discovered by Edward Franklin in 1852. After experimentation, he concluded that the number of atoms of one element with which an atom of another element may combine is directly a fixed number. It's a whole number. Each element has a number which measures its ability to bond with other elements. And valence electrons is referred to as the outside electron number. Hydrogen was used as a standard simply because it rarely bonds with more than one element, so it makes it kind of easy to determine what the valence electrons of the other elements are. And all this should be marked in your periodic table, the multiple colored one that we've done. Valence and atomic structure. Chemical activity depends on the number of electrons in the outer shell of the atom, as we've seen before with the data. There are certain groups that are more active than others, and it has to do with their valence electrons. Atoms with a full octet are considered to be stable, and these are called inert. They're also our noble gases. And all the other atoms want to get to a level of stability like the noble gases, and so they will bond and make bonds in order to get that configuration. Atoms with incomplete shells combine with other atoms with outer shells that are also incomplete to make 8 octets. And these atoms may share, lend, or borrow electrons. Chemically active. When we're talking about things being active, that means that their electrons are able to give or take or share. Okay? So noble gases are not chemically active. They are inert, so they don't want to bond with anybody. Valence describes how many electrons are gained, lost, or shared when atoms join other atoms. And it determines how atoms will combine to make compounds. Again, noble gases do not combine. They are inert. They have a charge of 0. They have 8 valence electrons with the exception of helium, which has 2, but that still makes it a full octet for all of them, even though helium only has 2 because level 1 only has a spot for 2. Why it's important. The knowledge of valence electrons leads to the advancement in analyzing known compounds and also synthesizing new compounds. All those medications you take, we had to have some kind of understanding about how they combine in order to make those compounds. Okay? Valence electrons and chemical bonds. Valence electrons are the outermost electrons. The number determines the valence number. Okay? So like group 1 has 1. Group 2 has 2, Group 3 has 3, Group 4, and so forth. Okay? They will determine how your chemical bonding is going to be achieved. Okay? We've already color-coded and we've already set that up. A chemical bond is a process by which atoms combine to form molecules, and only the valence electrons take part in this. The inside electrons will not take part in this bonding. They are protected and they are drawn closer to the nucleus. There's a shielding that's going on. Chemical bonding is the exchanging or sharing of one or more electrons between atoms which unite in a chemical reaction. A chemical bond is a force or link which holds atoms together in molecules or crystals. Van der Waals is the weak force that is attraction between atoms, molecules, and surfaces. There's also electrostatic, dipole, or dispersion. But it is a weak force and it's important in chemistry. It determines what's going to happen. And there's more than just van der Waals forces, but van der Waals is the basic one. Main types of bonding. So we have ionic bonding, which is a gain or loss of electrons. I also mentioned that this is metals and nonmetals bonding together. It's a better word for this is a cation, C-A-T-I-O-N, and an anion, A-N-I-O-N. A cation is a positively charged ion, which is usually going to be on your metal side. And then an anion is going to be negative, which is on the nonmetal side. But we also have to keep in account our polyatomics can also be bonded as well. Covalent bonding is a sharing of electrons in pairs. We normally are going to focus on carbon because carbon is usually the one that is most likely to share electrons. Metallic bonding we'll discuss in second semester, but your valence electrons are loosely held in the inner parts of an atom. They're free to move within a metallic crystal, and so it's bonds between metals. It gives the properties of ductility, malleability, and conductivity. So we've been working on symbolism of atoms, which includes the Bohr and Lewis model, and this becomes important when visualizing what's happening. Okay. Ionic bonding. Atoms may join by the process of losing and gaining electrons, and it can be one or more electrons. The bond that is formed is called an ionic bond, and chemically active atoms have a strong tendency to form a stable electron configuration of the noble gases. They want 8 electrons in the outside shell, which is also called an octet. They want their subshells to be filled. And so basically they're going to make and break, they're going to make bonds by giving and taking electrons in order to get that configuration that they desire. Ionic bonds, group 1, 2, and 3, they lose their electrons. So alkali metals lose 1, alkaline earth metals lose 2, boron atom family loses 3. So it's positive 1, positive 2, positive 3. Groups 5, 6, and 7, the nitrogen family gains 3 electrons, oxygen family gains 2 electrons, and halogens gain 1 electron. So a negative 3, negative 2, negative 1. If you do recall, halogens are the most active of all the families because they're going to get what they want. Noble gases are inert. They do not form bonds. They are monatomic. Monatomic means one atom. Everybody else is trying to get to 8 valence electrons or a full octet.